students, in the previous lecture we learned the reactions of metals with acids, bases and salt solutions. Now we are going to understand how metals react with non-metals. In 9th standard we have learned that metals have a tendency of losing electrons to achieve a stable electronic configuration, whereas the non-metals have the tendency of gaining electrons to achieve a stable electronic configuration. This is because the metals have either 1, 2 or 3 electrons in their outermost shell, whereas the non-metals have 4, 5, 6 or 7 electrons in the outermost shell. So, to complete their outermost shell or the octet state, metals lose electrons, whereas the non-metals gain electrons. The same thing happens when the metal and non-metal react. Metal loses its electrons to the non-metal atom, and metal atom turns into positive ion and the non-metal atom turns into negative ion. Since opposite charges attract each other, there is a force of attraction between these oppositely charged ions, which is called as ionic bond. And the compound which is formed by transfer of electrons from a metal atom to a non-metal atom is called as ionic compound. Now let us see the process by taking example of formation of sodium chloride. To understand this reaction, we will first see the structure of sodium atom and chlorine atom as shown in this model. Sodium atom has 11 protons in the nucleus, that means its atomic number is 11. So the configuration of sodium atom will be 281, which we can see from the structure. In the first shell there are 2 electrons, in the second shell there are 8 electrons, and then in the last shell there is 1 electron present. In case of chlorine atom, it has 17 protons in the nucleus. So its atomic number is 17. Electronic configuration will be 287. There will be 2 electrons in the first shell, 8 electrons in the second shell, and 7 electrons in the outermost shell. In order to complete the octet, the chlorine atom needs 1 electron, whereas to achieve the octet state in sodium atom, it has to lose this 1 electron, which happens when the sodium and chlorine atoms are mixed together. When they are mixed together, atom of sodium transfers its 1 electron to the atom of chlorine. Due to this, the number of electrons in the sodium particle becomes 10, whereas the number of protons are 11. So, there arises a net charge of +1 over this particle. Now, this is no more sodium atom. It has turned into sodium ion. So, we have to write this structure is of sodium ion, and its electronic configuration will be 2s. Now let us see what happens in case of chlorine. Chlorine has gained 1 electron. So now total number of electrons in chlorine are 18, whereas its proton has only 17 protons. So what we see that there is excess of 1 electron here, and therefore it has a negative charge on it after gaining 1 electron. So this is no more a chlorine atom. It has turned into chloride ion having configuration 288. Now these ions formed are attracted by strong force of attraction which is called ionic bond. That means they are no more separate and there is a attraction between them. So this they are combined together to form sodium chloride molecule. Now, to represent the formation of sodium chloride or any ionic compound, it is very difficult to draw such the whole structure. So, a convenient method is to draw electron dot structures of the participant atoms and ions and represent it. So, let us learn how to draw electron dot structures of atoms and for ions. Now, in order to draw the electron dot structure of sodium atom, write the symbol of sodium and draw the number of electrons present in the outermost shell of that atom by showing those many dots. Like sodium has 1 electron in its outermost shell, so we have to draw 1 dot near it. So this is electron dot structure of sodium atom. Now for chlorine atom, same method, write the symbol first. It is having 7 electrons in the outermost shell, so draw 7 electrons around it. We can use cross symbol for representing it. This is chlorine atom. Now, when the two are mixed, 1 electron of sodium is transferred to chlorine. So, show it by means of an arrow. After the transfer, sodium will acquire positive charge. So, sodium ion will be represented as Na. Put it in a bracket and write plus sign here. And chloride ion will be represented as like this, with 8 electrons, 1 coming from sodium and remaining electrons of itself and negative charge. So this is the electron dot structure of sodium chloride molecule. Right? Same way we can write the structure, electron dot structure of magnesium oxide and its formation. So let us discuss that. Magnesium chloride has formula MgCl2. So first of all, we will draw the electron dot structure of magnesium. Its atomic number is 12. So configuration is 282. It has 2 electrons in the outermost shell. Now MgCl2 means 2 atoms of chlorine are involved to form one molecule. So we will draw 2 electron dot structures of chlorine atom like this, having 7 electrons in the outermost shell. These are chlorine atoms, and this is magnesium atom. Now 1 electron from the magnesium is transferred to one of the chlorine and another is transferred to second chlorine atom. Show it by means of an arrow. Now magnesium will acquire a positive charge of 2 plus, and each chlorine atom will turn into a chloride ion having -1 charge. So its structure will be like this, having 7 electrons of its own and 1 coming from magnesium. Like this, there are 2 chloride ions, so we will write 2 here, and the charge over 1 chloride ion is minus. So this is the structure of magnesium chloride. I hope it is clear to everyone. Now we will discuss the properties of such compounds, that is ionic compounds. We see that ionic compounds are formed by transfer of electrons from metals to non-metals, forming ions which have strong force of attraction between them. So ionic bond is very strong. That is why ionic compounds exist mostly in solid state. They are hard because the bond is very strong between the ions. It is difficult to break that bond. Secondly, the ionic compounds are good conductors of electricity only in molten state or in aqueous form, because for conduction of electricity, free ions or electrons are needed. When the ionic compound is in solid state, the ions are strongly bonded to each other. They cannot move. So, solid ionic compounds do not conduct electricity. But once they are melted, they are free to move, ions are free to move, and they conduct electricity. Third property is solubility. They are soluble in water and other polar solvents. They are readily soluble. And the last property of the ionic compound is they are good conductors of heat also. So that is all for today. I hope you must have understood all the points clearly. Thank you so much.